Okay guys, today's video is going to be on vehicle grounding and how the grounds on cars and trucks work when it comes to the radios and other devices and all the car electronics that are inside the car already. I have here two separate devices. I have a radio here and I have a dome light here. And right now they're completely separated from each other. The dome light is a typical one of old school, where it's just getting one wire providing the 12 volts for the power, and then it gets its ground from being connected to the roof, a little bracket on the roof and a screw terminal there to complete the circuit. And of course the metal on the roof is welded to the rest of the chassis, and that has a connection going back to the battery. So if I disconnect the connection to the battery, my dome light goes off and I'll lose all my current. I'm drawing an amp there. So let me come back and hook it back up. Same if I lose my connection to my roof. If that loses its connection to the battery, same thing. We lose power to the dome light. Now this over here is a radio, and I'm in the same situation with it, to where if I remove the ground from it, it'll turn off, and if I put the ground back on, it'll come back on. Wanted you to look that the dome light here is drawing about an amp, and the radio over here is drawing about 3/10 of an amp. So, and this is your ideal situation where they're both not connected to each other. But I wanted to show you the reality of what happens in vehicles, and that is that there's shared grounds and shared current paths all over the place. And let me demonstrate that by showing you what happens when we screw in our radio to the roof with our coax cable. If I can get it to screw on here. So this is, like I said, this is in every typical vehicle, and they have your coax cable coming up, and it's going to have a braided grounded cable on it that pinches the roof up here and gives it that connection. And if you're looking at the meters, you can already see, oh, we've had a change in the balance of the current. We are now drawing almost twice as much current over here, and the missing current is from this one. So for whatever reason, the dome light here, light going back through the radio instead of back through this way. And this is a good demonstration of how these things find their own level, and it's strictly a matter of parallel circuits, and current flows in all of them simultaneously. No matter if one's a very poor connection, it's just proportionate to what the other ones draw. Is strictly by Ohm's law. So in a vehicle, you could have thousands of different little individual connections through welds, through different pieces of metal touching each other, all different kind of sorts of connections, and they all act simultaneously, and they all provide a split of that current. Now in this case right here, I showed how if I lost my ground on either one, that I'd lose my power. Well, now let's take a look at what happens when I lose my ground for my dome light now. Hey, the dome light's staying on, and now all my current is going through the radio. So it compensated for it, and you had no idea this happened because the light had no indication at all that it had lost its ground, because it had a perfectly good ground going the other way. Now let's take a look at the radio side here. We can see we're back to half and 0.7. If I lose my radio ground connection, now all of a sudden I can get power for my radio through my coax. And now the roof ground is providing all the current necessary, and there's nothing connected here whatsoever on my ground. So if I come over here to my antenna connector and I disconnect it, I lose power. So let this be a demonstration for you of how there's no separating these grounds. The ground on the roof is going to be touching the ground here no matter what, because these are isolated things. Let me give you another example of how it can get power as well. So you say, well, it can come in on the antenna connector. So I'll put the radio back on over here. Now let me show you if I disconnect it. All right, and I come back here on the radio, the coax connector. It powers up there. Also, if I come over here and go to my chassis, it'll get power and go through here. So I'm powering the radio right now through a screw hole that's going through, and still ground is ground. So all of these things share a common thing, and the electricity is just finding another way in. Now the big thing that you don't want to do is you don't want to try and run high current through any of these alternate ground spots. Which would happen is if I tried to key it up, that's when you would notice that's not a good enough ground to do that, and you'd have a lot of issues with that. So let that be a demonstration of how ground will find any way it can to work. So if you have a vehicle mount and the screws on the bracket are drilled into the sheet metal beneath the carpet, well, then that bracket is grounded, and now the little slide things that hold the radio in place, when you tighten them up, they rub up against the metal, so now there's an alternate connection there. So once again, all of this current, including some of the dome light current, will now be going through the bracket, and it's all ever present. What's important to have is to have a home run connection at the master ground connection at this device, so that it will never experience a voltage drop going back to the battery. And that's what causes all the issues, is that when you don't have a good ground connection going back, and this spider web of connections flexes and becomes resistive and non-resistive especially as the vehicle moves, it changes the instant voltages that are felt back here at the radio. So essentially, as it's seeing, it's fluctuate, and that's what disturbs the electronics in it. And then the other thing is that when you try and do a high current draw, like when you transmit, or if you have a light bar and you turn all your lights on, then very micro resistive connections that were never an issue. If you have a 0.2 of an ohm connection, and you're less than you're an amp, that's only 0.2 volts. But if you're drawing 20 amps, that's 4 volts. So that's enough to drop you down into reset territory on the radio. So that's what's the big difference on the all the 1,000 different low current connections, and having one good solid all the way to the source connection. So this is my demonstration on how the grounds balance, and you'll always have DC current from the devices going through your coaxial cable to the radio, but you want to make sure that it's just as small as it possibly can be, by making sure everything has a proper route to ground already. So I'm going to shift the video now out to the vehicle, and I'm going to go over the proper location of your ground in a vehicle. So stand by for that. Okay guys, we're out here in the vehicle, and this is our common ground and hot bus that we're going to be using to hook up the light bar and the radios here in the behind the back seat. And I just wanted to show you on both the power and the ground connections here where we're going to hook them up in the front. So if we transition over here and head up here to the front, I got the main power coming in here and going to this circuit breaker back here in the back corner over here, and its input comes over here and connects on to the main power connection here at the battery that I have disconnected at the moment. And just as a general rule, you want to make sure that anytime you have a fuse or a breaker, that it's within a foot or 18 inches, somewhere close to the battery, so that that lead that goes from the battery terminal to the fuse or the breaker is as short as possible, because that's a live wire, and if something shorts on it, there's nothing to stop it but fire. So you don't want to mess with that. So try and keep, like I said, as short as possible without being in the way of anything. Look for something that might come down, like a bolt hole or something, to make sure you have clearance and nothing's going to get crushed. So now I'm using a wire here just to show you. This isn't my actual ground wire, but I wanted to use it as an example to show you the three possible spots that you could select over here for your ground. Now, a lot of people would come over here and put their ground right on the ground terminal of the battery, and that is absolutely wrong, because if you lose your connection over here to your chassis, now everything in the vehicle is going to try and run through your ground cable to make it back here to the battery. And if it's the starter ground that comes off, that'll be the one it uses, and that can really fry things. So remember trying to have all that starter current come through, like your antenna connection and stuff. So you never want to go directly to the battery, although this is the best connection spot. It's too dangerous a spot to choose. So the next best spot would be over here, and that is where your factory wire comes in and gets its initial chassis ground here. And you would think, well, let's just fit in right underneath here and share this one. Well, that's a bad idea for two reasons. The first reason is that this is there's integrity to this, and you don't want to mess with that factory integrity. And they torque at a certain special amount, and et cetera, et cetera. So you just don't want to mess with the factory ground in any way. And also, if you were here together and they both lifted off, and once again, you'd be in the same situation where all the current would try and come through your cable to get back to the battery because it lost its chassis connection. So the best spot to connect is somewhere that's mechanically close, and I found a spot right here, which is on the same metal bracket as the factory one here. And you can see I've cleaned away the paint here, and I'm going to come in with a bolt and nuts and secure this. Well, it's going to be routed the other way, but it'll be secured with nut and bolt. So yeah, so that's the rule that you want to try and do, is get as close to the factory connection as you can without being in the factory connection, and absolutely always avoid the battery post itself. So okay, hope this helps. Talk to you soon.